Our second talk will be about practical analytics in energy and resources. We'll learn about approaches and the challenges in implementing analytics and machine learning in asset-intensive industries. Our speaker, Andrew McHardy, is a senior manager with Omnia AI, Deloitte's Canada's AI practice. He has over 20 years of experience in engineering, analytics, and project management. Andrew focuses on asset-intensive organizations, leveraging advanced analytics and artificial intelligence to enhance capital projects delivery, asset management, operations and maintenance, production and process control, and workplace safety. So let's invite Andrew to grab the mic.
All right, thanks very much. Everybody hear me on the opposite sides of the room? We're good? Oh yeah, thank you. Right, it's great to be here, and actually I feel a little bit ashamed because it is my first AI Geeks event, and so after 2 years I'm finally here as well. You can read into the title Practical, which this is not going to be an overly technical presentation. I do want to focus really on business value and sort of how we got there, how we, what we've certain clients and what the value they've realized through AI, and some lessons learned through that. So I'll mention some techniques, but really what I'm trying to do here is tell a little bit of a journey through the business and where we see AI playing a part. The title says analytics, and you'll forgive me that that a lot of what I speak about will involve a blend. It's analytics, or it's finding the right tool, and that's a theme I think I want to talk through as well. So the focus is on energy and resources, and here in Toronto, although we've got many large global mining companies, and we've got utilities, and we've got power generation, power transmission, distribution. So there's a lot of energy and resources based out of Toronto. But we don't often talk about that when we're thinking about AI. Often, we turn to other more leading industries, healthcare, retail, financial services, financial sector. But there's a huge uptake in energy and resources and a real opportunity there. So I'm going to hopefully convert some people in the room today with a few practical examples. My examples will focus a little bit on oil and gas and mining. But again, I think there's sort of a common theme or common trends across the energy and resources sector, which is very relevant to this audience and the conversation we're having today about the future of AI. Next slide. Can we advance that? There's not that many slides, so we should be okay. Okay. All right, there we go. All right, so I'm going to put that down. So we'll start with Industry 4.0. Does that mean anything to anybody? Does that ring a bell? Industry 4.0. How about the fourth industrial revolution? There we go. Industry 4.0. That's the terminology that we're hearing across the energy and resources sector. And it really, what is that? It's a lot of things, but certainly it's about smart autonomous systems that fueled by data. Right, or powered by data, powered by analytics, powered by AI, and we're seeing a real uptake in the energy and resources sector, and it's about changing the way we work. So it's not just baby steps of digitizing the way we work today. What we have out there in capabilities is actually fundamentally changing the workplace, the work we do, and the workers themselves. So a few examples of why that's happening. Certainly the abundance of technology, AI being one of the big drivers out there. It's hot, it's caught people's attention in the energy and resources sector, and it's got them thinking, saying, what are we doing? And so from the board all the way down, there's this dialogue going on saying, what are we doing that's keeping us to be competitive in the market? It certainly is changing jobs, it's changing careers. There's just this massive tsunami of data. And that's, I think, if you look at the evolution of analytics, energy and resources sits somewhere down at the bottom. They've been collecting data for a long time. When you think about energy and resources and the kind of processes and operations, They're highly sophisticated. There's lots of sensors. There's lots of data being generated, and it's been collected over 10, 20, 30 years. But of late, with advanced, IT, OT, we're seeing even a greater volume of data that we need to leverage. So just some common themes there around Industry 4.0. Next slide. So we dive into that and we think about energy and resources. This is not exhaustive, but there's sort of 4 things in energy and resources that I think are really relevant to the conversation. The first of all is keeping people safe and protecting our environment. That's hot within energy and resources, as you can imagine. And if we look at that, a lot of the environments we're talking about here they're just hazardous in nature. We've got people working at heights, working in confined spaces. We've got hazardous and volatile gases and compounds, heavy industrial operations. So you can imagine that a business value that energy and resources is looking to from AI starts with keeping people and our environment safe. The second is it is energy and resources, so it is about extraction of resources, and that could be, it jumps to mind, mining, oil and gas, getting things out of the ground, but that's also capturing energy, wind, solar. It's the whole spectrum. So let's think about that, and how do we effectively gather that energy or those resources to put them to use. The next is asset performance. A common theme across energy and resources is that it's asset intensive, right? So lots of equipment, lots of systems, lots of infrastructure, and that takes with a lot of capital, which leads to one of the challenges that with that much capital in play, any change is met with resistance because it often has a large capital or a financial impact. And the last is energy and resources companies they want production growth, sustainable growth, optimization. So how do we do those industrial processes? How do we run those more efficiently? Now, challenges and opportunities, and I think most of these read actually more as challenges than opportunities. But as I mentioned earlier, there's a mountain of data there, and it's probably the ugliest of all. Anna mentioned that no data is clean. Well, I think some of the data that we see in energy resources is got to be the ugliest of all. A lot of it's very unstructured. There's a lot of data that's been collected. Yes, there's sensors and streaming data that we've been collecting, but there's a lot of field observations and data that's been generated by operators and collected that has immense value, but up till now has been sort of nascent. So AI and some of the techniques we are aware of, can help us to extract value from that. Complex process and operations, we're dealing with energy and resources. It's a highly advanced, sophisticated from an engineering point of view. And so, layering on analytics and AI onto that certainly comes with challenges, and change in the way we work is a challenge. I talked a little bit already about the capital cost and asset intensive and what that means. And the last one is security and cyber. I think that's probably ubiquitous across any analytics or AI endeavor. We're conscious of that. But it leads back to that first business value around safety and environment. Sort of breaches in security or cyber can have just extreme impacts. So the energy and resources obviously very focused on that as we're trying to collect more data or automate or have sort of autonomous systems. That's just a major consideration. Move on, next slide. Okay, and I'll just pause here for a second, but really, this is, again, not exhaustive, and Anna did a great job of sort of, telling the story about AI and how we sort of corrupted some of these terms. But I threw this up there because there are some things that jump out that are very relevant to energy and resources. Computer vision certainly and with all the sensors and video and images that are being captured, has a lot of relevance. Machine learning, but natural language processing, a number of those that have a lot of use cases that are relevant to energy and resources. And I'm going to dive into those a few now. So we'll go on, just bounce a couple slides forward. Okay, the first one I'll talk about is safety. And it's characterized by traditionally large unstructured data sets. If something happens in the field, there's an incident, we capture lots of observations. Maybe we've got some data that surrounded that incident. Maybe we've got sensors, maybe we've got video, maybe we've got imagery. So there's a lot of data there that often in the past when we analyze an incident, we just look at what happened at that particular point in time. What we're able to do through analytics and AI is paint a much broader picture and what were all the sort of sequence events leading up to that. The other thing that's here, and it's one of the challenges I think in energy resources, is bias, right? Not bias in the data, which is I think probably what a lot of people thought about when I said that, but bias in the operators, right? That there are sort of fundamentally held truths about what is good safety or good environmental controls. And I'm not saying throw away any of that, but there's opportunities to challenge that, and that comes with some resistance. What we're able to do in some of these applications of analytics and AI in safety is to be able to sort of deconstruct it, to look at more objectively what are factors contributing to that event, right? The event being some sort of near miss or safety or environmental event. So by sort of going through this, it allows us to tell that history, to look at really factors that would have been potentially otherwise disregarded. We also are trying to change behaviors. So, how do you change behaviors? Well, you try to provide fact-based evidence. And so again, when we're looking at safety, and safety ultimately comes down to how individuals act within their environment. So how do you change those behaviors? Well, part of that is exposing them to data, exposing them to some of the insights that we can generate, and it's hard to argue against. So some things that are insights that may be surprising, but certainly objective, and trying to influence the way that people act. The other thing is we're also identifying lots of new ways. If we now have ways to analyze the data, then it opens the door to say we should be enabling people in the field to collect data points, to take pictures, to take video, and because we now have the ability to analyze. We have the ability to we can analyze them on a much smaller scale. AI gives us scale, right? To be able to ingest that, to be able to look through it, to take obviously input from the operator, to be able to build the models that then can produce insights that tell us, is there a risk or is there a potential risk at play? So some things to think about there from a safety point of view. Again, sort of a practical application. Move on to the next. So there's a specific one here, and often, like going into these cases, are the companies we work have hypothesis. They already have a problem identified, and they're saying, we need to bring an analytics or AI solution. That's got to work. First thing we do is actually see, hey, is there actually signal? Is there actually enough data that's available, that's accurate, that's complete, that allows us to actually generate some sort of a model to be able to solve that problem? Often it's not the case, or often it takes a number of iterations to get there. Ways that we need to transform the data, ways that we need to seek out other sources of data that may not have been readily available, or to just, to go through a number of different techniques to find one that actually works. In this case, it was our neural networks that actually produced the greatest lift in the case that I'm talking about here. I'll jump down. Like there was some real tangible value here. This was for a SAGD operation. If you know, it's how we get oil out of the ground in the oil sands by injecting steam and reducing viscosity, so then we can extract oil from the earth. That's an expensive endeavor, and getting that formula right is key. So that was the problem that the client was really looking for here, and trying to optimize that. In this case, they wanted sort of one answer to the problem. We had to sort of dissect that into separate models. So one that helped us sort of identify events. So as that operation was going forward, and there's sort of anomalies that occur, we need to be able to advance, see those in advance. So that was going from a matter of hours to days in terms of our ability to predict those. And the other thing was actually being able to sort of optimize that steam-oil ratio in this case. So how much steam, how much energy we need to consume to actually get oil out of the ground. And again, we're going from sort of days to months in being able to give that sort of notice. So what that does, and there's tangible value you can calculate from this, which I suppose is one of the differences about energy and resources is as we go through and we look at these use cases, it's always about what's the investment and what's the return, and often we can calculate a tangible return. So in this case, at the early stages saying, do we have signal? Is there value? What do we need to do to get there? And then obviously trying to capture that so that, we can run pilots and we can scale that across the enterprise where it's applicable. Last one. Okay, this one was interesting, and it's to do with predictive maintenance. And if in the mining industry, maintenance of their operational costs, maintenance is about 30 to 50% of the cost of operating a mine. So that was our client was in the mining industry. In this case, it was actually it was their logistic or transportation network they were concerned with. So they owned and operated a length of track and all the rolling stock, trying to move materials from the mine to the port. And they had sensors, and they had actually an instrumented car that would traverse the track, and it would collect data, largely vibration, right? So they had operators in there, so they had field observations, and they were going over the track and they were collecting vibration data and using that along with observations to say, is there degradation? That was not answering the problem. There was a lot of false signals. They were either repairing track that didn't need to be repaired, or they were in most cases, they were incurring emergency maintenance. So you can imagine a remote area, you have a track failure, the whole operation shuts down, and that's not just the movement of that material. It affects the mine, it affects the port, it affects the downstream operations. Huge costs involved. So the operation was not optimized. One of the things we're able to do is actually collect imagery now, and not now. This is not brand new technology or new algorithm, but certainly there's a greater acceptance or willingness to explore this. So that was it. What was really taken on here is how do we take all of that data, sensors, vibration, as well as imagery, and still operator observations. Those are still a huge valuable input to this model, and develop a model that allows us then to detect, in this case, in the next 30-day window, what is the likelihood that specific section of track is going to incur a failure. If we can do that, then we can plan maintenance, then we can plan production, we can plan logistics. So that was a huge value for, in this case, only enabled because there was a willingness to sort of look outside some of the traditional data capture, to challenge sort of some of the traditional thinking around maintenance, and to believe in this model, and that belief in the model that it has validity. It was not an overnight process either, right? Gaining the confidence of maintenance personnel who have been doing this for 30 plus years, and now you're introducing a new input to that thought process. It's not a simple change, but huge input or value for the client, and beyond that. So not just detecting failure, but actually understanding failure, understanding at a deeper level why things are failing and what it is, the interaction between different systems and components, to be able then to design and maintain smarter. So that's sort of another practical example I just wanted to bring to light here. That's the last of that. I guess, a couple thoughts to leave you with. I focus a lot here on value, on business value, which as we go through this journey with many companies in energy and resources, it often starts with some pilot projects, solving some critical problems to gain confidence. What's interesting in that is in terms of approach, I'll make an observation around how do you get there, and often we're dealing with organizations and cultures that have taken a very sort of methodical approach, an engineering approach to a problem, which goes from first principles and really understanding that, and then working a very deliberate way to the end, right? And in the way they deliver projects, capital projects, going a very sort of either waterfall or traditional project management approach that says we've got to define the requirement very clearly up front and then start to do our work. So what we're really challenging that by bringing sort of AI to the front, because it's got to be more iterative, it's got to be more agile. It has to sort of go on, certainly bringing all that experience and knowledge that we have resident in our engineers and supervisors and managers, but combining that with some of these insights we can generate. And so it does take there's a bit of a mindset shift there, and it's certainly something we're experiencing. And I'll say a small a agile, but that agile mindset to be able to experiment, to iterate, and then to build trust over time, to be able to implement something like this, which maybe contradicts, a belief that's been held for a career. So I'm going to stop there, and I think we got some time for some questions. Yeah. Okay. Anybody?
Hi, very quick question. Thanks for the great presentation. Thanks for the great presentation. A very quick question.
Sure.
So we have data from the vibration sensor. How are the data getting from the operator's observation? How do you inculcate that in the model?
Yeah, interesting. So I mean, you've got basically operators identifying like an anomaly. Like there's a way to obviously to sort of go through that and characterize, the observations. In this case, it was more just sort of saying that that the operator has detected some kind of an anomaly. They had an app which they're in this. You imagine this is a controlled car, instrumented wagon that's traversing the track. It's collecting all this data through sensors, as well as wayside cameras that we've got. So it's all that's collecting. But they've got operators in there as well that are making field observations, and they're saying, at this point in time, I noticed something. What allows us, that's not always, there's error in that, of course, right, as there isn't any, but it allows us to take, that's a data point that we can test and start and learn from that, right? And again, we are going to have some false readings and false positives that come out of this. But that's more what we were looking for, that the operator, that there's some anomaly detected or observed by the operator. It's geo-referenced, and then we can say what else did we observe through different inputs at that point in time, and thereby that's how we were able to sort of build out some of the models. Make sense? Thanks. Any other questions? Yeah, in the middle. I'll go over here next.
Thanks for the presentation. I have a question based on the that's profit analysis on the business side.
Yeah.
Looking at it, it's quite cost effective to implement such applications and everything with AI. How do you guys get to convince a client to put this in place, and how it's like saving them millions of dollars in the front run? Thank you.
Yeah, I mean, I got to be honest. Like, I think the business case is often really very clear when you look at the investment up front to even do a small proof of concept or pilot project, and the return easily 10, 100 times to the business. How do we? But it's not always easy to sort of get that exact number at the beginning. I think what we're trying to do is show, as we have examples and as the industry produces examples, to sort of use that as a way. So each problem is going to be unique in itself, and we need to analyze. But it's sort of looking at sort of relevant other work that's been done and trying to bring that in. The business case is often very, very compelling. Like, it's as I said, small investment for a large return. The bigger challenge is actually not necessarily that value. It's actually about how does the organization need to adapt to that, and whether or not there's uptake from the operators and engineers to actually do things differently, because that's more of the change, and whether the organization is willing to do that. So it's a bit of a two-part discussion. Yeah. Sure. We got. I think we had one over here. Now we picked on the middle too much. Wait.
Oh, more of us.
Yeah. I'll be around after if you want to.
More kind of a business question.
Sure.
So once you develop this model, do you keep the model and then keep charging the client, or you sell? There is some handoff and you sell the model to the client and let them deal with it.
It's a great question, because there's a lot of learnings, right, that we get, but there's reusable assets there, right? Or and obviously not the model that we can just sort of plug and play, but the approach or the methodology, certainly that's reusable. In many cases, though, it's IP that we're either sharing or handing to the client, saying, for your specific use case, here's what it is. But there's a learning, there's approach, there's sort of methods that are tested out to say, a problem with these sorts of features and these sorts of data sets or complexities, we get smarter and we learn to how to sort of approach that a little more efficiently. I think this is what this is this environment too, right? This is all about learning faster as an industry or as a group of practitioners. So yeah, there's always I suppose there's competitiveness built into this, but haven't hit that as much of a hurdle, to be honest, right now, and maybe because the industry is a little earlier on. But yeah. Cool. All right.
Yeah, just one more.
Oh, do we? Okay,
Yeah.
sure.
Thank you for the talk. I had one question. Well, the other day, someone actually told me that batteries have revolutionized electricity storage the way that refrigerators have revolutionized milk storage.
Yeah.
So what's your opinion on trading electricity like stock with demand response algorithms in place and then having that electricity stored and conserving it? Where do you see that part of the energy resources sector taking off with AI?
I might need you to clarify a little bit. I'm not sure I quite understand the question. Can you just?
So it has to do with like demand response algorithms. So when people see that, like say electricity prices go up, then they're more willing to conserve and store their electricity. So at some point, like I think there are companies in Canada right now where they have like EVs storing electricity, like you can store electricity there and then power it to your commercial building or I don't think they've done it with residential buildings yet, but do you see, like where do you see that part of the energy resources sector taking off? And will people be trading electricity like stock yeah.
Jeez,
Yeah.
That's a great question. I don't know if I can actually provide a really good answer to that.
Okay.
I think you've actually made a great sort of statement more than a question, to be honest. We should have stopped after 3. That would have been much better. Yeah, I think I was doing good up until that point. I don't know that I've got a good answer for that. It's like these are sort of the ideas that I think are very disruptive in the industry and saying like I don't know how do you trade that? I think it's one that we can take away. I don't know that I've got a great answer for that though. But thanks. Yeah.
Okay.
That's it. No,
Thank you.
seriously, that's it. Thank you very much. Thanks.